I must talk about the staff of Radiator and Tinning. The first African that really joined me was Philemon Mazizi. And then he brought his brother along, Dooley. And so we got two brothers working together. And slowly the staffing, then we ended up with Doobie, December. There's so many. We ended up with a staff of 550 people. So I don't remember all their names. But the first one, Philemon, he worked with us in the garden, first of all, and then the first workshop. And he retired, fortunately, and he got his pension. But all the others that were in our pension scheme, because of the devaluation of money, they lost out. And I always feel not guilty. It wasn't my fault. It was a national problem. But it's one of those tragedies. There was December, Doobie. There were so many. Now, I can't remember all the names now, but I think of them all, and I must admit, I always give a little prayer for them. There was fire, and each one had a little skill of his own, managed to do things, because I'd organised it a little bit. They were all specialised in their particular jobs. It was really a wonderful place, really, with the people. I'll go back to the first workshop, 15th, which was 15th Avenue, Jameson Street. The works were getting much too small for us, so we found another place in Fife Street, and it was part of Anglo-African glass. And of course, I knew the lady who was in the glass there. She was very nice, and the next door neighbours were the Winterbores. They were always very pleasant. But Paul, when he was about 4 or 5, he took a washer into Mrs. Winterbore to get change, and she changed it for a penny or something like that. And he took a washer in. He was in his little overalls. When I think back of all these instances, we moved into this workshop. And Peter, Radiator Industries in Harare, he was Colonel Horsburgh was running that firm. And regrettably, Peter was very much a gentleman's gentleman, but he went pop, and I bought his machines. Now, how I managed to get those machines to finance it, it was £1,900 for a complete Mark III Lawrence machinery. And I went to the IDC, which was, fortunately for me, Freddie Wigley was on the board, and Dr. Fiscal from Bartashu, he was the chairman. And they almost squashed my little amount of money that I wanted for industry. But Freddie Wigley said, look, you don't support Bulawayo in any way. This is a small amount. Let's accept it. So they did. They lent me the money to pay for Peter Horsburgh, and I got those machinery. That was a complete Mark III fin, tube, and header plate press, all complete, and an oven, and the oven was the standard Mark III oven. Fortunately, we got enough electricity. There was a yard outside, so we used outside for all the acids baths and that. And the city council made me put in a special drainage system for. It was a tank down underground, all in concrete, which rubber lined for the anything that had got acid in. And then it got a wall in it, and it separated the sludge away from going into the drains. I forget, there's a special name for that particular drain. But we were there for quite a long time, I suppose about 5 or 6 years. But, but one day, a lady came in, an African lady came in. She was rather, in those days, when I first arrived in Zimbabwe, the African people were badly dressed. They were very, very, I don't want to use the wrong words, but they were just very, very raw. It was, and I used to supply all the overalls, all their clothes for the workers. So all their overalls and boots and things like that. And so my team were fairly well dressed. But this particular lady came in and she was well dressed and spoke well, and she wanted a Bedford radiator. So I asked her what model, and she didn't know what model it was, So I said, would you recognize the radiator if you saw it? And she says, yes. So I took her up the workshop, the whole length of, that was the Fife Street workshop, took her all the way up to the top. And she saw a radiator and she said, that's what I want. And she knew exactly what she wanted. And I found out later she was Princess Luanika of the Barotse tribe. And she got a lot of vehicles. So that was an amazing sort of thing to meet somebody that knew what a radiator looked like, as also a princess. In the Barotses years ago, I don't know if they get as much water these days, but they used to be all in canoes and that. We developed at Fife Street there. We're next to Dormer Diesel's, Harold Edwards, and I used to go in and chat with him. He was on the front, his workshop was on the front, and Harold had actually put the engines into Jersey, the big, not Dormer, I forget, they were great big Merley's engines for the power station. And so we got a connection with Jersey there, with Harold. But after a while, that workshop got too small. So we moved from there to further along Fife Street, and we bought the first property there. Again, I went to IDC, and that property was worth £4,000. It was only small. It was the built-up area was the same size as the other workshop, Fife Street, and but the yard was big. It was on half an acre of ground. So when we moved, we planned it and got the tanks in place or new tanks in place in this new workshop, and when it came to moving, each one picked up his own job and walked to the new workshop with his own job in his hand, and he could start work right away. We got the gas, the acetylene, and everything in place. So it's really quite a remarkable thing we did there. And then after we'd been there a while, that was a bit small, and I managed to get a hold of a dual form press from Jack Lawrence. Now, Jack Lawrence was the man who made the machinery, the Mark III Lawrence machinery. And I made a friend of Jack in a way, in that the first press he made, an experimental one, the table size was 24 inches. Now, because it was only 24 inches, it wasn't capable of pressing, the dual form press wasn't capable of doing a Chevrolet top tank, because a Chevrolet tank was 23 inches and if the platen was only 24, you couldn't get it on. That was the main platen. So he opened the platen to, I think it was 42 inches wide, redesigned the press on my not instructions, but on advice. And he actually sold me a press at a discount for the mere fact that I had helped him to design his first press. Now these presses, I couldn't make it work, but we had great problems trying to make it work. You've got, with this press, it's got jewelite, which is a bismuth alloy, which melts with hot water. And we got this installed, and we tried to make this. We got first of all, you got two plates. One was mounted on the top of the press. One was based on the floating on this metal, the jewelite, or the bismuth alloy. And what you did, you actually got a existing tank, and you cut a hole in the plate to put it in and glued it with, glued it and put tape around it, and you put to make up for the thickness of metal, you actually got wax paper, and you put that inside, and it was quite. Well, the first tank that was made successfully was made by December, and I could have kissed his bottom for he brought a tank into me, a Land Rover top tank in his hand, made. And I tell you what, I was so thrilled with him. And December got a job for life working that press, and he made it sing. He did all sorts of things on that press. Really, he was a very, very good chap, December was, except that poor old December always got himself into trouble. He actually killed two people. One of them, a burglar, was at his house, and he threw a rock at him, or a brick that was in his garden, and he threw it, and he hit, the chap was running away, and the brick hit him on the head, and he died. But we took him to a lawyer, and he went to court, and he was let off. But he did it twice for some. The sort of thing happened to him twice, to December. But the lawyer said to him, if you do that a third time, he says, I won't get you off. And that was December. But we had a lovely crowd of people. We developed the site slowly. We got all the machinery into place. Then we slowly built our lean-to on the other wall of the factory. So we got an open yard, one factory, and then the other side. And that's where we put the dual form press in there. Eventually, it's got its own location. We were getting a lot of scrap metal and old radiator cores, and the scrap dealers were giving us a pittance for scrap. So I had to find a way of how to make it commercially viable to do something with the radiator. So I rang up the mines department, and I said to them, look, I've got a radiator here which is virtually 100% copper. I want to know if you can electro-win it like you do a mine. And I said to her, the words I said to the chap was, you get a ton of rock, you crush it, and you get a pennyweight's worth of gold, and you think you've done well. Well, I've got a 95% copper unit here, and I wanted to convert it. So what do we do? So he laughed over it, and he said, send me a sample. So I sent him a sample. I cut a piece of radiator, sent it up to him, and he tried to electrowin it, and it wasn't successful. So he melted the sample and put it through a spark. He said, you know, that alloy that we've resulted from it is a straight gunmetal. It's 5% tin, 5% lead, 5% zinc, and the rest copper, 85% copper. He said, that is a straight gunmetal. Now, what can you do with gunmetal? Well, I'd always been interested in tinning because the name of the company was Radiator and Tinning. And so the tin research had got books, and I used to get these books regularly, or leaflets from tin research. And they one day had an article on continuous casting of bronze. Well, that was an idea. So what Trevor did was make contact with tin research in London, and I went over to see them. And Fry's Metals, who I used to buy all their solders, so I'd got a relationship with Fry's Metals at Tandem Works, and they were doing this continuous casting. So I went to see their facilities, and they were on a mezzanine floor, and with the furnaces was a main furnace, then a holding furnace, then an extraction unit, and it went down to the ground floor, the product. Well, I looked at it, and it looked so simple for me. I thought I can make that quite easy. And the tin research gave me a lot of help too. So I went back to Zim, and I made a gearbox, and I put this unit. I made the furnace. We got the crucible, and fortunately for me, the gearbox that I made was with the ordinary gears. And if I'd have been successful, well, I was successful in a way in that one, but I realized the gearbox was dangerous because they were ordinary gears. And when the weight of the product was in the gears, it could actually pull the product out of the furnace through the water jackets and actually run away. And I could have caused an explosion. So what I did to overcome that problem, the gearboxes, I went out and got Peugeot differentials. Now they've got a bronze gear and a pinion across the bottom. So what I got 5 of those differentials, and made a very, very strong box that it was in. It was virtually 1-inch plate, all of it. And those, so that I turned one, being as though the crown wheel and pinions, they couldn't run out on their own. So it was a very safe gearbox, really. And then I got special motors to drive them. Was really I was an experimental thing that we did there, and the furnaces were upstairs. I had to build a building, and I eventually got 6 furnaces upstairs, all oil fired, and then lower down, mounted lower down, was the actual small crucible with the die-in, so that the molten metal was poured first, melted first, then poured into the tin dish, and then it went through a carbon die, which was machined, and then into a water jacket, and then underneath was a saw which was a Trenjager saw, beautiful saws. But they were very special, and they got small bodies, so that the blade, carborundum blade, I used to use 28 inches diameter, but because of the motors in the middle, I could only use 6 inches or 7 inches of the blade. Then the blade became scrap, because when it got down too low, other than cutting small diameter bronzes. But we could do up to 6-inch diameter, either hollow bar or solid. We were doing not only the bronzes we were doing were not only solids but hollows. And so if you imagine a 6-inch, you got a wide range of bore diameters. So we ended up with huge amounts of metal that we were producing, and so we ended up with huge stocks of metal, of bronzes, which we were selling throughout the world. We got an agent in Newark, in New York. We got we used to sell a lot to non-ferrous metal works down in Durban, gone to Lazarus. We had a very good relationship there, and we had a good relationship with all our customers. We sold to Australia, everywhere, wherever there was a market, we got. Now the British, after UDI was finished, the British government, well, I don't know if it was even before that, but I used to work in with there was an office in London which aided firms to sell their products worldwide. And they would, if you told them what your product was, they'd send you a list of all your likely customers worldwide. So we got this list of all the likely people to use bronze throughout the world from the British Trade Commissioner. It was just off Fleet Street, their offices. It was a little tiny office. I went to see them and I got all the paperwork from them. And they kept in touch with us always. We had very good relationships, the company, with the British High Commission in Harare, and they always visited us. Radiator and Tinning was a wonderful firm as far as I was concerned. It had its own little hospital where Paul's wife worked, and she had a helper there. She bought aspirins by the 1,000 in a tin, and if the staff, they went there and they got their aspirins. They got condoms there as well. Everything, when they had the HIV, everything was, it was a wonderful little place. We had a school room upstairs in the new building. One of the things that we got was, because we got extrusion presses. Now the extrusion presses, the first big one I bought was from Switzerland, from Metalwerken in Dornach. Well, that's not quite right. The first press I got was a small one. It was a couple of castings which I'd got, and it was only the ram on that, I think it was 100 tons. So I could only do small diameter rod on that, sort of one up to about 1 inch diameter, because with the continuous casting, I could make the billets. Now the billets were in that particular press were 4 inches. So, and with the extrusion, it's all mathematics. The size of the die, the size of the product, and all that, and so that you get the right pressure onto producing a product. Then the bigger press that I bought came from Switzerland, from Dornach Metalwerken, and that was 1,200 ton. Now that was a water press, and that press. No, I'm sorry, that was an oil press. But I needed a lot of horsepower to drive that. So I looked around and I found at the sugar estates on the Zambezi River, they'd changed over some electric motors. They were vertical motors, and that was ideal for me. And they'd got water pumps on, but I took the pumps off, and I put hydraulics on them, Bosch hydraulics on those units, and they were 500 horsepower each, those motors, and the pumps, they were delivered a lot of oil. Now I got two of those motors, and they were both hidden behind the wall. When I say hidden, they were just happened to be at the right place, just enough room for them. Very difficult to work on the hydraulics because they were like underneath. We'd made a frame that lifted the motor up in the air so we could get the hydraulics underneath. And that fed the press. Now, the biggest problem we had with the press there were some of the valves. And those valves were, it's funny, I could get the spares for those valves in Guernsey, but I only found out that by mistake. And it was quite a big thing. But then we were extruding copper, brass, and we had a run-out table for the, no, I've gone ahead of myself. We had just a run-out table for that particular press, and it was because it was a horizontal press, so it meant the product came out along its length. And then we had the African would grab hold of the end as it came out and run along, pulling it at the same time to the extent of the billet. Now in that press, we used 6-inch billets, so it was a much bigger product that we were getting out of that. Then I got another press, which I got from Birmingham, which was a Fielding and Platt, a fielding press, which was a vertical press, and that was 1150 tons. Now I had to put that on another mezzanine floor. I had to build the floor to put the press on. The biggest problem was when I bought that press, it was in an auction sale. It was in an auction sale, and when I was there, nobody bid for this press. Nobody. So I made a silly offer, and the auctioneer, Henry Butcher was the auctioneer, wonderful auctioneer, a very, very big firm. And I made a silly offer, and he was so angry with me making such a silly offer. He turned around to the directors of Cirque Radiators, who were selling the press, and said, "What do I do with it? I've got an offer, and it's ridiculous." And the director said, "Okay, take it." And I got the press for a certain amount. Now, I hadn't got the money there at that time, so I got my mother to pay for it. She bought the press, and eventually she invoiced it out to me at a price, and I had to pay her. There was a differential in the prices, a little bit of a differential there for her facilities. But that's how I got. So we ended up with 3 extrusion presses. Now that with the vertical press, we got accumulator bottles. Now those accumulator bottles were about 20 feet high, and or at least 30 inches, if not more, in diameter, and there were 4 bottles, and they were 3 of them with water, and the other one with air, and but it took, and they worked at close on 4,000 psi. So this the vertical press on the mezzanine floor, you put the billets in the top, and it came down, and the product went underwater, or it went over the top. If it was brass, it went on top. If it was copper, it went through the water. Now, in that trough, there must have been possibly as much as 1/4 of a ton of sludge, but it was all copper oxides and that, virtually solid copper. And but that comes to another story later on.